Good day, everybody. How are you all doing? Today, we are going to talk about confidence interval for population proportion. So, here I go. Okay. So, this section is on confidence interval for population proportion. As you know, we do not know exactly the population proportion. For example, if in a college of 15,000 students, they want to find out what population proportion of students have laptop computers. 15,000 students, population size. They cannot contact all the students because it's too time consuming. So most probably they have to work with several samples of the same size. Say we have 20 samples of each 100 students randomly selected. So for each sample, I will ask the 100 students, each of the 100 students, how many do you have a laptop computer? Suppose 80 out of 100 tell that they have laptop computers. That means my sample proportion of success here, success is to have a laptop computer, is 80 out of 100 or zero point 0.8. But that is a single point estimate of the population proportion coming from a single sample. Okay, it just gives me a point estimate. Will the population proportion be exactly zero point 0.8? Not necessarily. It may be above, it may be below, but at least it gets me a point to start off with. Ideally, I would like to have an interval or a range of proportions within which most probably the population proportion will fall. The range means it consists of a lower boundary and an upper boundary, a range of numbers within which the population proportion will fall. That is interval. Okay. Now the why confidence. Confidence is we will adopt a method which will give us a certain level of confidence. That means if we have 95% confidence in the interval that we have calculated, that means if I collect 100 samples and get 100 values of the sample proportion and from that calculate 100 intervals of population proportion within which most probably the population proportion will fall, 95 out of the 100 intervals will actually contain the population proportion. So the confidence level is the confidence in the success rate of the method that we have used to calculate this interval. So these are my goals. So I'm not going to go through the tables because I'm going to use a TI-84 calculator, which is the pretty much the norm these days. So TI-84 plus calculator. The National Association of Music Merchants surveyed 800 parents of children 5 through 18, and 632 of them said that music education has a positive effect on the academic performance. Assuming these parents to be a random sample, we would like to construct a confidence interval for the proportion. Notice the confidence interval for the proportion is in bold letters and highlighted because we are basically calculating a range of numbers within which most probably the population proportion of parents who believe that music education has a positive effect on academic performance will fall. So these are the notations we use. P is the population proportion of individuals who are in a specified category. X is the number of individuals and the samples who are in the specified category. Sometimes X is called the number of success, and we define in the problem what is success. For example, in this particular problem that we just now discussed, success is to believe that musical education, okay, music education has a positive effect. So success is the number of parents who believe that music education has a positive effect on academic performance. Notice my sample size is 800, out of which 632 parents believe that music has a positive effect on academic performance. So P is the population proportion of individuals who are in a specified category, that means success. X is the number of individuals who in the sample. So we jump from population to sample who are in the specified category. N is the sample size. P hat is the sample proportions of individuals who are in the specified category, or P hat is the proportion of success, sample proportion of success. P hat, the thing at the top is called P hat, is X over N. X is the small number, N is the large number. So here is it. P hat, point estimate, single value of the population proportion. That is why it is called point estimate, means one value, is X over N. We also need the standard error of P hat. This is the sampling distribution of P hat, whose standard deviation is given, is also called standard error. Standard error of P hat means the standard deviation of sampling distribution of P hat, which is bell-shaped and is spread around the mid, is square root of P hat times 1 minus P hat over N. To compute the margin of error, we multiply the standard error by the critical value. Again, margin of error is the maximum bound of error that we are willing to accept, and it is obtained by multiplying the critical value of z, critical value, that's z alpha by 2, times square root of the standard error, or standard error, which is square root of P hat times 1 minus P hat over N. Remember, the whole thing under the square root is the standard deviation of the sampling distribution of P hat, which is also called standard error. And Z alpha by 2 is what is the critical value of Z. So our level of confidence in this case, as you will later learn, is 1 minus alpha, which is the area in the center. And alpha by 2 is the area in each tail, on the left tail as well as on the right tail. So confidence interval is given as point estimate, which is P hat value, plus minus margin of error, which is the critical value of Z, times the standard error of the sampling distribution of P hat. The method for constructing a confidence interval for a population proportion requires that the sampling distribution be approximately normal. The following assumptions ensure this. We have a simple random sample. The population is at least 20 times as large as the sample, so that the sampled items are independent. The items in the population are divided into two categories, success and failure. The sample must contain at least 10 individuals in each category. What is the category? One category is success, the other category is failure. So one prob C int is the command we are going to use to calculate this interval. So we press the stat button, then highlight, means move the cursor on the top row to test, and then scroll down. You will not see it in the first screen, but you have to scroll down to the second screen by down arrow key, which gives you one prob C int. And then you will enter the value of X, which is the number of success. N is the sample size. C level is the confidence level, and we calculate. So in a survey of 800 parents, 632 said that they must, and that music education has a positive effect on academic performance. Construct a 95% confidence interval for the proportion of parents, that is the population proportion of parents who believe that music education has a positive effect. We begin by checking the assumption. Simple random sample. Yes, this is a simple random sample. It's reasonable to assume that the population of parents is at least 20 times as large as the sample. The item in the population is divided into two categories, success and failure. Out of 800 parents, 632 believe that music has a positive effect on education. That is, 632 is a success. So failure is 800 minus 632, which is 168. Both the number of success 632 and the number of failure 168 are greater or equal to 10. So we can assume that the sampling distribution of P hat is bell-shaped. And then we go to stat test. Again, scroll down to one prop Z int. Prop is proportion. Z int is Z interval. Type in the value of X, type in the value of N, type in the value of C level, and we calculate. What does it mean? With 95% confidence, we can state that the actual population proportion will fall between 0.762 and rounded to 3 places of decimal and 0.818. Again, that level of confidence, 95%, is the success rate of the method that we will use to calculate this confidence interval. That is, if we collect 100 samples and calculate 100 intervals from these 100 values of p hat samples proportion of success, we calculate 100 intervals. Out of those 100 intervals, 95 will contain the actual population proportion, the remaining 5 will not. Let's see if there's a problem we can do. Okay, here it is. A simple random sample of 200 third graders in a large school district was chosen to participate in an after-school program to improve reading skills. After completing the program, the children were tested and 142 of them showed improvement in their reading skills. So improvement in reading skills is success. Number of success is 142. The sample size is 200. So number of failures is 200 minus 142, which is 58. It can assume that it's a simple random sample as is given in the problem statement. The number of success is 142, number of failure is 58, both of them greater or equal to 10. Why do we need to check on that? We need to check on that to make sure that the sampling distribution of p hat is bell-shaped. Okay. So we are going to construct a 95% confidence interval for the proportion of third graders in the school district whose reading scores would improve after the completing the program. So we go. So part A is satisfied. Now we go to stat, highlight test on the top row. Then we scroll down, not in the first screen, but in the second screen, one prob Z int and hit enter. My X value, X is the number of success, is 142. My N value is total sample size is 200. My C level is 0.95 and I calculate. So with 95% confidence, we can state that the actual population proportion of success or actual population of students who show improvement in reading skills is between 0.647 and 0.773. Is it reasonable to conclude that more than 60%, that part C? So our confidence interval starts from 0.647, which is greater than 0.6. Therefore, the answer to part C is yes, it is reasonable to conclude that more than 60% of the students would improve. Now, if I were not to use the calculator, first I have to calculate the sampling distribution, the standard deviation of the sampling distribution or standard error, which is given by square root of p hat times 1 minus p hat over n. So what is my p hat value? It is 142 divided by 200, which is 0.71. So let's calculate the standard error or the standard deviation of the sampling distribution of p hat. The first thing we will do is press the second button and then x square button. Gives me the square root. Inside square root, first is p hat, which is 0.71. Then left parenthesis, 1 minus 0.71. And then the right parenthesis, everything under the square root, divided by the sample size of 200. Okay. And this is the standard deviation of the sampling distribution or standard error, which is 0.03208, etc. Okay, 0.32, you might call it 0.0321. So let's do 0.0321. Then we have to multiply it by the critical value of Z. Okay, remember the level of confidence is 1 minus alpha, which is 1 minus 0.05. Also, it is stated 0.95. So the critical value of Z with alpha by 2 in the left tail, alpha by 2 in the right tail. Alpha is 1 minus 0.95, 0.05. Alpha by 2 in the left tail means 0.05 divided by 2, 0.025. If you do second verse 3, area in the left tail 0.025, mean 0, standard deviation and 1, you will find the critical value is for 95% confidence, area in the center is 1.96. So multiply the standard error which you just calculated with the critical value, which is 1.96 in this case. Okay, so your margin of error is 0.0629. So what will be the lower boundary of the confidence interval? Will be the sample proportion, which is 0.71, minus the margin of error, which is 0.063, you might say, and it is 0.647. So lower boundary is 0.647. And what is the upper boundary? It is the sample proportion 0.71 plus the margin of error, which is the critical value, which is 1.96 times the standard error, which is 0.032. Okay, so 1.71, I mean 0.71 is the sample proportion plus the margin of error is 0.063 is 0.773. Notice the sample proportion of 0.71 falls in the middle between center between 0.647 and 0.773. Why it is? Because for the sample proportion, you go on the left by a margin of error, which is the critical value times standard error. And that is 0.647. And from the center, which is sample proportion 0.71, you add the same margin of error on the right and you get 0.773. And again, as I told you, for part C, 0.6 is greater than 0.6 is less than 0.647, or in other words, 0.647. The confidence interval starts from 0.647, which is greater than 0.6. Therefore, we can say it is reasonable. Yes, it is reasonable to assume or to conclude that more than 60% of the students would improve their reading score after completing this program. Then we are finding the sample size. I will straight away go to the formula. N is equal to P hat. That's a minimum sample size needed to maintain the certain level of certain margin of error and certain confidence level. Okay. Here P hat is the sample proportion. So N is P hat times 1 minus P hat in parenthesis Z alpha by 2, which for 95% confidence interval is 1.96 divided by M. M is the margin of error. What is margin of error? Is sample proportion minus population proportion. That will be provided to us and the whole thing squared. And we always round it up to the next whole number. So in order to use the formula N is equal to P hat times 1 minus P hat Z alpha by 2 by M, we need both M and P hat. We can set the value of M, but we don't know ahead what P hat. There are two ways to determine the values of P hat. Use a value that is available from a previously drawn sample. That is, in this case, P hat value will be available. In case 2, P hat will not be known. We will assume P hat is 0.5 and then calculate. Okay, let's go to a problem. Okay. Let's do part A. In a preliminary study of random sample, 100 computer chips was tested and 17 of them were found to be defective. So what is my sample proportion of defective? Will be 17 out of 100.17. Now another sample will be drawn in order to construct a 95% confidence interval for the proportion of chips that are defective. Use the results of the preliminary study to estimate the sample size needed so that the confidence interval will have a margin of error of 0.06. So we go to this formula. Okay. So P hat originally is known to be 0.17, 17 out of 100 and 95% confidence level. So Z alpha by 2 is 1.96 and our margin of error is 0.06. So let's go back to the formula. So P hat. So how do I use this formula? So I'll first type in the value of P hat, which is 0.17, 17 out of 100 to be defective. Then left parenthesis, 1 minus 0.17, right parenthesis. Notice I did not do 0.17 times. I just put the left parenthesis inside the parenthesis, 1 minus 0.17, right parenthesis, then again the left parenthesis. And Z alpha by 2 is 1.96 for 95% confidence level. And the margin of error is 0.06, last sentence. Okay. So 1.96 divided by margin of error, which is 0.06. Put the right parenthesis. Notice in the right parenthesis, after the last right parenthesis, we have to square it. We have to square it. How do I do that? Press the X square button in the first column after the last right parenthesis and hit enter. The answer is not 150.56. It is 151. The answer is 151. A pollster is going to sample a number of voters in a large city and construct a 98% confidence interval. This is the Z alpha by 2 we have to find on our own. Just a hint, 98% confidence means area in the center of the standard normal curve is 0.98. Total area under the standard normal curve is 1. So area in the two tails is from 1. We take out the area in the center, which is 0.98. So 1 minus 0.98 is 0.02, which is the area in two tails divided by 2 is 0.01, area in each tail. So area in the left tail is 0.01. This will help us to find out the critical value of Z. So we go second, verse, and 3. Area is area in each tail, which is 0.01. And we do not change mean and standard deviation. Go to paste and hit enter and enter. So the critical value in this case is 2.326. They did not give us an estimate of p hat. So we have to use p hat value of 0.5. So it will be 0.5 for p hat multiplied by 0.5 and then left parenthesis. What is the critical value? 2.326 divided by margin of error of 0.05. Put the right parenthesis and square the last one, x square, press it and hit. And it is 542. It is no way 541. We always round it up. 542 is the answer. We are not interested in this. So I'll stop here today. If you have any question or comment, write me a note. If you like this video, please give me a thumbs up. I really appreciate that. And if you like this video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. And please do not forget to watch me tomorrow when I will be back with another interesting video. Thanks for watching. Take care. Have a nice day and subscribe to my channel by hitting the red subscribe button. And please share this video with your friends. Thanks for watching. Take care. Have a nice day.